All right, welcome, ladies and gentlemen, to section 2 of chapter 4. This is where we're going to deal with graphing our rational functions. So in the last lesson, we talked about just finding things on our rational functions, where we found our vertical asymptotes, we found our horizontal asymptotes, we found our domain. So we're going to throw in some more things, finding a couple other objects, and we're going to use those objects to graph on graph paper. So the notes, you don't need graph paper, but when you do your assignment later on, you will need graph paper. So you got to make sure that you get some from me tomorrow. All right, so let's go ahead and go through the how to solve or how to graph these functions. So just a quick how to do it. One of the first things that you should do, this is one of many things that you need to do, you need to figure out what your y-intercept is, if you have any. And you find the y-intercept by letting x equal 0 and figuring out what the y value is. That's definition. If you plug in 0 for x, that's the definition of your y-intercept. You then need to find your zeros or your x-intercepts. And the x-intercepts occur whenever the numerator is 0. So if you had an x plus 2 over an x minus 1, your x-intercept is x equals negative 2. So it's the point negative 2, 0. That would be your x-intercept. In this particular case, if you found the y-intercept, if you plugged in 0 for x, you would get a y-intercept of negative 2. So you'd have the point 0, negative 2, the 2 over negative 1 there. Those are points that need to show up on your graph. You must have x-intercepts and y-intercepts if you have any. Okay? Note this statement here, if any. Sometimes you get none, and that's fine. You need to find the zeros of the denominator, and that represents your vertical asymptotes. Okay, that's the thing we were just dealing with in the last lesson. If you got like here, the vertical asymptote is x equals 1. So on your graph, you would do something like this. At x equals 1, I'd have a vertical asymptote. Later, you'll see I also tell you to find the horizontal. In this case, the horizontal asymptote is also 1. I have a y-intercept of negative 2 and an x-intercept of negative 2. So these are all things that you need to find before you graph any lines or any curves on your graph. So this is what I just mentioned. Your next step would be find and sketch the horizontal asymptote, if there is any. Remember, you can have no horizontal asymptote, but we're going to find slant asymptotes here in this particular lesson as well. And then number 5 is where we need to find some more points. So we just need to plot a couple more points that will help us see what the curve is going to look like. So in that last graph that I had on here, I had something that looks like this. I would want to test one. I would want to plug in one more point here and one more point here. And then I need to plug in some points up here to figure out that this graph goes like this forever. Remember, you can't cross your vertical asymptotes. And that would be the last piece there. Once you have dots that show you the direction of your curve, you use a smooth curve to complete the graph. So like I just did, I found some dots that went on my graph, and I connected those dots with a smooth curve. And I didn't mention this in number 5 here. Finding more dots just means plugging in x values. So let's look at a couple examples of sketching a graph. Let's find a good one here. Let's just start with 1 over x minus 2. So in the function 1 over x minus 2, we need to figure out some stuff. We need to figure out my vertical asymptote is x equals 2 because it makes the denominator 0. We need to figure out that the horizontal asymptote is y equals 0 because the denominator has more x's than the numerator. I need to figure out my x-intercept. Well, my x-intercept is when the numerator is 0, and in this case, there is no spot for that because there are no x's in the numerator. And my y-intercept is when x is 0. And if I plug in 0 to the denominator, this becomes 0 minus 2, which is 1 over negative 2. So it's 0, comma, negative 1/2. All right, so that's enough information to begin my graph. So I have a vertical asymptote at 2. So I'm going to come out here to 2. I'm going to put in a vertical asymptote. I have a horizontal asymptote at 0. So I'm going to put that in. I don't have any x-intercepts, but I do have a y-intercept at negative 1/2. So if this is a negative 1, that's a positive 1. Here is my y-intercept. Well, I don't really know what this is going to look like just yet, so I need to find some more points. If I plug in the point 1, 1 minus 2 is negative 1, and 1 over negative 1 is negative 1, so I would get a dot right here. If I plugged in 1.5, I would get a dot right down here, and you can verify this by just plugging this in, basically starting a table, and we already know we have the point 0, negative 1/2. We have the 1, negative 1. And then just find some more dots to help you out. You can plug in the point negative 1 and do things like that. And then you can connect the dots thusly. But there's always things that happen on both sides of the vertical asymptote. In this particular case, you would plug in numbers like, so if that's a 2, you would plug in numbers like 3, and 4, and 5, numbers on the right-hand side of the asymptote, and you would find that the dots followed some pattern like this, and you would connect the dots. And there we go. There is the graph of 1 over x minus 2. All right, let's try something else here. Let's try something a little bit more challenging. Let's start with x minus 2 over, let's already factor this for you here, this. If I were to graph this function, well, I can't graph it yet because I haven't done any of the dirty work yet. Vertical asymptotes. In this case, I have 2, x equals 3, and x equals negative 1. Horizontal asymptote, I have a square in the bottom and a linear in the top, and therefore it's just straight up y equals 0. I need to find my x-intercept, and it's whatever makes the numerator 0. In this case, it's x equals 2. This one's going to be a little bit tricky here, by the way. Then I have the y-intercept. I have to plug in 0. So I would get negative 2 over negative 3 times 1. And in this case, it would be negative 2 over negative 3, so it's 2/3. All right, so let's see what this is going to do here. Let's go 1, 2, 3, negative 1, negative 2, negative 3. So we need to... let's go that as a 1, that is a negative 1, and let's change some colors. All right, so we have vertical asymptotes at 3 and negative 1. So if I put out here at negative 1, that's x equals negative 1. And we have x equals 3. And we have the horizontal asymptote of 0. Now, we have, what else do we have here? We have an x-intercept of 2. And now some of you are cringing now because you're confused that it's touching the horizontal asymptote. But that's actually okay. Horizontal asymptotes have nothing to do with non-crossing. And I mentioned this in the last lesson. We're talking about end behavior, really. As x gets really, really big, it's approaching this dashed line. All right, we also have a y-intercept of 2/3, so we have something right up in here. And here's what I kind of do. I already know what the middle thing is going to do, and you actually, I should mention this, notice that there is a section on the left, a section on the middle, and a section on the right. There is something different going on in all 3 sections, okay? So here's what I want to do. On an XY table, I test very specific points. I want to test something really close to the asymptotes on either side. So since this is -1, I want to test -1.1, which is right here. -1.1 is on this side. And I want to test -0.9. What this will do is it will actually tell you kind of what it should look like. And therefore, you don't have to do a whole lot of dots. So I also want to test -0.9. And on the other vertical asymptote, I'm going to test the number 3.1 and 2.9. So I'm basically testing a number on either side of that asymptote. So here I go. I'm going to test 3.1 and 2.9. Sorry about the phone here. If I were to plug these things in, let me go ahead and put this in my calculator here. If you'll give me a moment. I have the function x minus 2 over x minus 3 and x plus 1. Now here's what I really care about. I only care whether or not it's positive or negative. So if I plugged a -1.1 in here, it's going to be a negative. If I plugged in -1.1 into this factor, it's going to be negative. And a -1.1 into this factor, it's also going to be negative. And 3 negatives make a negative. Now you can plug this number in and figure out that it's a negative something, but I don't care. If I plug in -0.9, the numerator again is negative. My first factor is negative, but my second factor is now positive, so it makes this a positive value. If I plug in 3.1, 3.1 minus 2 is positive. 3.1 minus 3 is positive. And 3.1 plus 1 is also positive. So that whole thing is positive. And then lastly, the 2.9. The numerator would be positive, negative, and then positive here. So I get a negative. Now, what does that mean? Negative means below the x-axis. So at -1.1, so on this side of the asymptote, it's negative. That means it's down here. And you'll notice, actually, it's very negative. So in this particular case, we are going to do a sketch where it comes up and comes over like this. It approaches this horizontal asymptote and approaches this vertical asymptote. So this would be this side. And you can test dots. If you want to put more dots in there, you can go ahead. Notice on the -0.9, which is on this side, it's up here. So it actually is a positive value. It's going to come down. And then at 2.9, it's negative, which means this is going to come through here and do this. And the 3.1 is positive, so it's going to follow this particular pattern up here. This would be the graph of this function. All right, let's go ahead and move on to slant asymptotes. Slant asymptotes, if you recall, occur when the numerator is greater than the denominator, when the degree. What we're going to be doing is if the degree is exactly 1 more than the denominator, and that's the only ones that we're going to be dealing with, it has what we call a slant asymptote. What we're going to do is we're going to do the stuff that we did from last chapter. So we're actually going to do some long division. to figure out what the slant asymptote is, and we're going to graph that slant asymptote. So in this case, we don't have horizontals, but we have a slant asymptote. So let's take a look at what that's going to look like here. So here we go. We have a function that looks like this: x squared minus x over x plus 1. We notice that the numerator has one more degree than the denominator. So we're going to do a quick x plus 1 division into x squared minus x. Multiply by x, we get x squared plus x. We subtract, we get negative 2x. Notice that there's a plus 0. We multiply by negative 2, we get negative 2x minus 2. And when we subtract, we get a 2. So if you remember how we wrote our answers before, we have x minus 2 plus 2 over x plus 1. This right here, or this thing up on the top, is my slant asymptote. So when I go to graph this function, we need to also continue to do the same thing. Vertical asymptote is x equals negative 1. No horizontal, but we do have a slant, and the slant asymptote is y equals x minus 2. We have the numerator here is x times x minus 1, so we actually have 2 x-intercepts. We have the x-intercept of 0, 0. It's whatever the numerator makes 0 there. And we have the x-intercept of 1, 0. And if 0, 0 is an x-intercept, it's also the same y-intercept. Okay, so if we go to graph this function, we need vertical asymptote at negative 1. And then we have a slant asymptote of x minus 2. Well, the line x minus 2 goes through 0, negative 2, and goes through here because the slope is 1. And that is our slant asymptote. I'm sorry, I'm crunching across the bottom here. I didn't leave myself enough room. Now we need to use the other pieces. We have a x-intercept of 0, 0, and 1, 0. And the y-intercept is 0, 0. If we were to test points, what is this? Negative 1. So if we were to test negative 1.1 and negative 0.9 on this side, we would find that it would be positive here. And it's going to come down here like this, because it's going to go down below and then come back up. And then it has to follow this slant asymptote over here as best as I can. And then if you were to test negative 1.1, you'd actually find out that it was negative. And it actually would come down here. This is why I said I'm sorry about crunching the graph here. And it would be this little piece down here. Notice something has to occur on both sides of the vertical asymptote. In this particular case, it looks like this. These are pretty interesting looking graphs, I think. We're not going to be doing it, but you could also have asymptotes that were quadratics or cubics. They get a little bit more ugly, but we're just going to be dealing with linear slant asymptotes. Let's try one more really quick. I think we can get through this one. Let's try the function x squared minus x minus 2 over x plus, oops, sorry, erase. Actually, I have an eraser now. X minus 1. So first thing I like to do is I just like to factor the numerator. So this is x minus 2 and x plus 1. So I have a vertical asymptote at x equals 1. I have no horizontal because the numerator is bigger than the denominator. So I have a slant asymptote. I don't know what that is yet. I have x-intercepts of 2 and -1 because that makes the numerator 0. And I have a y-intercept of -2 over -1, so 0, 2. So let's figure out what the slant asymptote is. Doing some long division, stuff we should be very familiar with now. Multiply by x. Subtract, subtract. We get -2. So we have a slant asymptote of y equals x. All right, so a slant asymptote of y equals x is going to look like this. This is y equals x. We have a vertical asymptote at 1. Then we need to put in all of our other things. We have a x-intercept of -1, 0, and 2, 0. We have a y-intercept of 2. And again, if you were to test the numbers 1.1 and 0.9, 0.9 you'd notice is a positive value, and it's going to come down here like this. Connect those two dots, and I just missed. Let's try that with an eraser there. Hey, look at that. Okay, this is going to come down here, and it's just going to keep coming down and follow the asymptote. You'll notice down here at 1.1, it's negative. It has to come up and cross that number, and then it's going to come up here and approach the asymptote. I think that's going to do us for today. I hope you learned a little bit more about rational functions. I'm going to give you guys the assignment here. All 8 of those, and all 8 of those better be done on graph paper. So see me tomorrow for the graph paper, or print some off of your own. All right, I will see you guys tomorrow.